Continuation term in microprocessor basic is complexity. Complexity is nothing but a simply requirement of hardware. How much hardware is increased? So while the number of transistors are increases, automatically requirement of hardware is increased. So in microprocessor complexity, the Moore's law statement states that it is the number of transistors is increased for every 18 to 24 months. This statement is represented as a Moore's law. As per Moore's law, we are going to identify 1971 first microprocessor is invented by Intel company. Later we are going to see the increase of the ICs are like this. For number of transistors also increases like this. By year 1972 2000. So every transistor and the number of usage of the number of transistor means embedding a transistor or integrating number of transistors are also double. Here the statement is the number of transistors are double for every 18 to 24 months. The statement is represented as a Moore's law. Here the main point is complexity is nothing but a requirement of the hardware. The number of transistors should be doubled every 18 to 24 months related to Moore's law statement. Next one is the communication. What is meant by communication? Communication is nothing but a exchange of information or sending information from one place to another. That means exchanging information both sides. That is called communication. In the microprocessor case, we are going to consider two types of communication. One is the serial communication. Second one is the parallel communication. In serial communication, we are going to expecting serial cable only. Serial cable that is represented like this. Suppose if sender has, that means 1011 0 1 0 0 like this. This information will be represented like this. This information is transferred through the serial cable to receiver. So here every digit it needs one clock pulse. This binary digit needs one clock pulse. This needs one clock pulse to transfer. Every binary digit needs one clock pulse. That means how many clock pulses are needed? So if you consider here 4 and 4, total 8 bits is there. 8 bits means 8 clock pulses are needed to transfer complete information from sender to receiver. In this case, in parallel case, here at a time, here for every digit, every binary digit it transfer with the help of only single wire. So 8-bit information is there from the sender. At a time, those 8-bit information is transferred through this buses. At a time, 8 wires we are going to receive 8-bit information from the sender to receiver. That means in serial communication, serial cable is expected in between sender and receiver. In parallel communication, parallel wires we are going to expect it in between sender and receiver. So what is the advantages and disadvantages? Here advantage means simple establishing. The connection is establishing very easy. So only single wire is used, automatically the requirement of the hardware also very less. So single wire is used, the cost is also very less. So sender to receiver, here the one more important point is the number of clock pulses are very high. Number of clock pulses are requirement of the clock pulses are very high compared to the parallel communication. Coming to the parallel communication, number of wires are increases, automatical cost is increases, automatical complexity problem is also increases. But compared to serial, parallel transfer technique is very fast. So simply statement, serial communication is the outside the computer communication. That means external communication. External communication, this is called the internal communication. External communication is nothing but a long distance communication. This is the short distance communication. So long distance communication is CPU to printer. So that is a long distance. From one place to another. Suppose if the 2 kilometer distance is there, that means in between two areas. This type of communication we are using sender to receiver. That means serial communication is used. In this case, parallel communication is used within the CPU, within the computer. That is called internal communication, or it is used for the short distance. Inside motherboard, modules are very nearer to each other. That means here parallel wires are connected in between these two modules. So automatically the data processing is increases. While the data processing is increases, automatically system processing is increases. System processing is increases, automatically performance of the system is also increases. So in internal communication, we are using parallel communication. Outside or external communication is used to serial communication. This is the long distance communication. This is the short distance communication. One, random access memory, read-only memory. Types of memory. This memory is called the primary memory. Primary memory, random access memory, read-only memory. Random access memory is classified into static random access memory, dynamic random access memory. Here, programmable read-only memory, erasable programmable read-only memory, electrical erasable read-only memory. Electrical erasable programmable read-only memory. SRAM, that means static RAM. So if the power is suddenly switched off, the complete information will be erased in this memory. So little bit time it will force with the help of capacitor circuits. Here, programmable read-only memory. These are the advanced technology for the user flexibility. ROM is implemented. So this is a permanent memory. This RAM is a temporary storage memory. Programmable read-only memory with the help of programmable concept. Programmable techniques, we are going to erase the even if is there any error is occurred inside this read-only memory. With the help of programmable concept, we are going to erase the particular error. So at a time, this memory is allows only one-time return only. That means one-time return will allowed by using this EROM. Here EPROM indicates erasable programmable read-only memory. With the help of UV rays, we are going to erase is there any error occurred inside the read-only memory. So coming to the electrical erase means electrical signals. With the help of electrical signals, so we are going to erase is there any error inside the read-only memory. We are going to avoid that error with the help of electrical signals. PROM, programmable concept, EPROM, UV rays, ultraviolet rays, and EPROM, electrical signals. Coming to the little bit points about this random access memory and read-only memory. This is a temporary storage memory and permanent storage memory. Temporary means it is a volatile memory, non-volatile memory. So random access means randomly access the memory. That means read property and write property will allow this memory. And only read property is allowed. There is no write property. That means how can you read the every time data? That means once it is written, so that property is completed. Written property is completed. That means this memory is called another name. Write once, read many times memory. So this is a manufactured flexibility memory. This is a user flexibility memory. User can always access with these memory locations, not these locations. Always we are going to reading the instruction from these memories. Read-only memory program is fixed. While it is booting the computer from the initial, that means the starting button, that is called bootstrap program. With the help of bootstrap program, the computer we are going to turn on. So while it is a turn on, read-only memory programs comes into the picture. It will handle the computer processor. Next one is the coprocessor. Coprocessor is nothing but it is just like acts as a friend of the processor, main processor or multi-core processor or single processor, whatever the processor we are using. Coprocessor acts as just like as a friend. That means while it is executing with other tasks, that means while it is busy, sometimes this processor needs some calculation from the various sources. That means other processors, that is called coprocessor. That means it takes some help from the coprocessor. That particular instruction will transfer to, while it is busy, some instructions are transferred to coprocessor for the processing. Coprocessor comes into the picture. Whatever the task is assigned from the processor, coprocessor will perform that particular task. After completion of the task, result is generated. Again, that generated result will transfer to the processor. This is a task is performed by the coprocessor. Whatever the task is assigned by the main processor, coprocessor will perform the particular task. So what are the examples of this coprocessor? In 8087 is used as a match processor. Match processor means it will calculate these mathematical calculations, mathematical applications we are using. And mean some match processor, matrix processor like this. These are the titles of the coprocessor examples. The coprocessor is a computer processor used to supplement the functions of the primary processor. CPU operations performed by the coprocessor may be floating point arithmetic, graphics, signal processing, string processing, cryptography, or I/O interfacing with peripheral devices. Next one is the bit. Bit is simple. It is a binary variable, either logic 1 or logic 0. So here see the bit. A bit short for binary digit is the smallest unit of the data in a computer. So with the help of binary values only, we are going to processing the data. So every CPU receives binary values from the input devices. Binary values, it processes binary values, it transfers to the output devices also in the form of binary. It receives binary, processes binary, transfers the binary. That means a combination of zeros and ones. So here every digit, single digit is simply it is called as a binary variable or single bit. Next one is the byte. Byte means a group of 8 bits, 8 binary digits. A byte represents 8 bits and is the most commonly used term relating to the amount of information stored within a computer's memory. 8 bits simply it's called a byte. Next one, nibble. Nibble means a group of 4 binary bits. 4 bits, or it is a half of a byte. Next one is the word. So word is a 16 bits. 16 bits. Double word in the sense 2 into 16. That means 32 bits. Single word, double word. Here word is 16 bits or 2 bytes. Accumulator. Accumulator is a very important. Another name of the accumulator is a working register. Accumulator, another name is working register. But working in a sense, the main thing of the accumulator is always it provides the input as well as the output. It means input which it will provide after completion of the particular task or execution of any instruction. Again, result also it will holds like this. So that accumulator will provide input and receives the output from the ALU. So result of the arithmetic logical operations always go to the accumulator, connected directly to the output of the ALU. Here working register is nothing but accumulator. Suppose while it is a processing, it provides one input to the ALU. So another input we are receiving from another source or another memory location or register. After execution, the result again it is stored inside the this accumulator. In this case, ALU is the most commonly used register compared to remaining register. This is a general purpose register. Compared to remaining general purpose registers also, accumulator is the highest accessing speed. So general purpose registers are accumulator, base register, count register, and data registers. Out of these four, accumulator is the highest accessing speed. The accumulator is a register for a short-term intermediate storage of arithmetic and logical data in a computer CPU central processing unit.